A special advantage of decision tree models is that those models are white box models. One can investigate how those models deals with the data. That is different from models such as neural networks. Even the performance are similar, but decision tree models are more interpretable, and that might be useful in practical problems, such as, for example, when you are trying to predict the risk of particular customers in financial sector, you might need to explain your decision to your customer or to your like both. So in scikit-learn, there is a visualization function that comes very convenient when we would like to investigate the decision tree models that's been built to fit data. The function is called the function itself is to export a constructed decision tree into a special coding, and that coding can be visualized by graph visualization tools. So let's have a look. To export a decision tree object, we first need a file. For example, let f to be a file object. Let f to be in Python. You can use open to create a file object. File object, you can consider it as a permanent container into which you can write information, and later you can load it from that file, and the file is of course saved on the disk instead of in the memory. This is more permanent than a variable. You can consider that is a special kind of a variable that is not volatile, that can be preserved. Okay, let us call that arrays classifier dt. The encoding of the file is done in plain text, so we need this file object for writing purposes. Okay. Generally, when you try to create such an object, it's different than a variable you try to create in memory, which normally you will expect. When you create a variable, you have a variable, but for a file object, there are some possibilities that you may fail to create the file, such as when the disk is run out of space, or you try to create a file on a path that is pointing to a non-existing directory. So there are many ways for these operations to go wrong. So if you create a file object, you will need to check if the object has been created successfully or not. And after you have done with the file, we need to close the object. So let me write it here. Check validity of f, and write the decision tree information to f. And after those operations, we need to close f. This is because the close operation, we call it flush all the cached information into the disk, because we can imagine that the input and the output rate of the disk is much slower than that if we are operating information in the main memory. So when we try to dealing with information in disk, many operating systems will create a buffer in the memory, and or when you read or write to disk instead of directly access the disk, operating system may save the recently used information in memory, and the entire methodology is transparent to the user, but the user's experience is that the disk is much faster than it is actually is. But the downside of this kind of manipulation is that when, as a developer, you try to preserve some information, sometimes in many cases the information is temporarily saved in memory. If you leave it without pay attention, you may end up with missing information, and this kind of error is quite difficult to localize and correct, because you cannot reliably repeat the problem every time. So it is a good habit to close a file object after usage. But in Python, actually, we do not rely on a good habit in Python is we don't rely on the programmer's good habit to deal with all these different stages of file operation. There is a context construction in Python. We call it with. So with this operation, and let the result of opening this file as a file object. This construction will do the opening part, as well as check if f is valuable, and so we do not need to do this ourselves. And embedded in this construction, we can do all the operations with f. After we're done with f, we do not need to worry about the closure, because it will be done automatically by the with that is called a context. Okay, which is very useful. Now we have summarized the file opening and operation in one line of code. What we need to do next, is to write the information of the graph to f. This function is provided by scikit-learn's tree submodule. The function name is export graphviz. Graphviz is a tool of realizing graphs, and this function will export our tree into some format that can be explained by the tool graphviz. Look, a tree is a special kind of graph. Okay. The object is our classifier C, and let the out file to be f, which we open and use here. We can give the names, feature names, let it to be our data feature names. If you remember the directory of the data object, this directory provides you the feature names. Sorry. Class names, target names, and we can specify some attributes of the graph, such as fill color to the nodes, okay, let's try it. Done. Let's check our directory. in week 3 directory, in the working directory, let us list the files. Look, now we have a text file just created by the instruction. There is a graphic tool. If you are using a Mac computer, you can install the tool. The tool's name is called GraphViz. I already have this one, so let me show it. Dot and let the output files format to be a PNG picture, and let's use the Iris classifier.decision tree. Okay, let us have a look. Now we have a new PNG file. Okay, this is our tree. If you are not using a Mac computer and you are comfortable with using online tools, there is also a convenient way of visualizing the tree classifier object. Let's Google it. You can just put Google here and online GraphViz. Look. After trying, I found this tool is particularly useful, called GraphViz Online. The address is dreampath.github.io. Let's try this one. It accepts pure text here. So in our case, we can go to the home folder and find the text file, click it, just copy all the text here to this part. See what we have. Well, this is our tree.